So welcome to the session number 2, Scientific Spotlights, Scaling Trustworthy AI and Robot Learning. So our first speaker, please a warm welcome to Ralf Traphöner. He studied computer science with a focus on AI and economics in Kaiserslautern, starting in 1984. He then co-founded a startup called Tequino GmbH at that time, which dealt with case-based reasoning in 1991. And this later became part of the company Impolis, where he's now employed and where he took different roles from research and development to the managing director. And today he is a principal consultant and has the project lead Easy. And his mission is to develop new business ideas utilizing data, AI, and analytics. So welcome, Ralf Traphöner, and we are very much looking forward to your talk.
So welcome from my side as well. I have to admit that I was not aware that the talk has to be in English, so you will see some German mix-up in the slides, but hopefully they are comprehensible anyway. When I was invited to come here, Tom Kraus was the reason. I actually felt a little bit alien, because we don't do audits, but we deal with scaling applications. And so maybe I can contribute some interesting aspects from practice. So I present the Easy project, and it has a complex title, which is usual for research projects in Germany. It deals with analyzing data to achieve different objectives. One is to be able to dynamically control how software is executed in the edge cloud continuum. It's meant to use metrics to optimize those systems, and of course, to do AI and analytics applications on data in industry. So let me put it into some context. I stole this picture from the IPSAI CIS, but it shows a little bit the overall picture. I guess you know all these pictures and also the terminology that you see on the bottom. When I talk to SME clients, they only know edge and cloud. And the edge is what is on the left. Their machinery, their control systems, and maybe some industrial PC systems. And everything to the right from there is cloud in their terminology. It doesn't matter whether it's on-premise. If it's on-premise, it's a private cloud, fine. But all that is cloud. And that's the setting in which we are developing Easy. The idea is we should have the same execution environment on the edge as we have in the cloud. So if you want to develop an application for analyzing data, for example, current that you measure on a machine, it should not matter whether you execute that on the edge or in the cloud. What matters is what are your requirements regarding latency, energy consumption, etc., to control where to execute this and automate that process. Because as an SME, you don't want to care about all that stuff. So from that, we've developed an architecture and implemented it, which exactly allows that. So you can develop in the cloud, move the function to the edge, and you don't need to change anything. It will just run. And based on that idea, you can imagine practical applications. So in this case, we talk about a palleting robot. The idea is that every time that the robot has a problem, it reports, for example, an error code. All that takes place on the edge. So top left, you have the robot. It reports, and the operator has his HMI where he can see what the data is that comes from the robot. Maybe he can make a decision how to act already on that, but the analysis system will help him to interpret the data in the right manner. And only the result of the analysis is going into the cloud, wherever that is. And there you have supporting applications like, for example, in this case, knowledge management, that helps you to classify the problem, to find the right solution, and to execute that solution, maybe even with remote access to the robot system and the control of it. So that's what we do in that area. And picking up on the previous talk, I was thinking, okay, I have another case that we do. That's about the measurement of the wear of drilling tools. And in that case, I mean, you can imagine there are thousands of drilling machines out there in industry. Every machine, every process is different. So simply training is an AI system to classify the wear of the drilling tool is not possible. It simply will not work. We need to calibrate and retrain that on each process. Not just the machine, also the specific process, how fast it works, which torque it has, and so forth. And since most of the machines out there are old, we need to do that with simple means. So we just take the current of the spindle. And using that, we can classify the wear. The problem is we must retrain all the time. So we apply federated learning to get a robust model that can be adapted easily to the specific process. We use a global model. So it's an autoencoder, and the encoding part is trained as a global model, and the decoding part is trained as a specific model for each process on the machine. And all the time when the process changes, we get a new model. That was the question that I had. I mean, we must retrain on the job to do that. And we must measure the quality of the trained model on the job, on the edge. And so each edge does have some gold standard for the specific process that is acquired during setting up the process. And every time the model changes, we must evaluate against that local standard to be sure that we don't trash our quality by using a new global model. And the key here is, in terms of green IT and cost, it's much cheaper to bring the function to the data than the other way around. That's something that we have clearly learned. And as said, we use metrics to control that process, where to execute what. After 3 years of working with this data, I'm quite sure as long as you have the computing power on the edge, do it on the edge. Don't move the data into the cloud. And this has another aspect to it. If you compute on the edge, your data stays on the edge. It stays on your premise. It can be isolated and thereby secured, and it gives you sovereignty in the sense that you are in control of the data, and you can be sure that it's not misused outside of your premises. And here I was mixing up English and German for a specific reason. I think the right technology to share data are data spaces. And I think the concept of factory X, manufacturing X with the MX port is meaningful. It will solve a lot about on the trust and security side. Important here, why I mixed up German and English, is in German we say Sicherheit. And we say Sicherheit always, independent of what we are meaning, whether we mean security or safety. Just as a reminder, safety is securing the human against the machine. And Security is saving or protecting the machine against the evil human. And that's what we can achieve with data space technology and with edge computing. That's it from my side. Also, yeah, one important thing. If you want to learn more about what we've done there and you are not planning for a Christmas party on the 11th of December, visit us at the Bosch campus in Wenningen, where we have a day of the stuff that we really produced in the project. Thank you.
So thank you very much for this insightful talk. Are there any questions? There's one question here.
Yeah, thank you so much for the talk. At first, when you were speaking about that the system has the same environment, whether it's on the edge or in the cloud, I first thought of Docker environments, to be honest, but I mean, your applications are different. My question is, like, how do you maintain systems that are out there in the field if you put also the functionality out in the field? Maybe with different version updates and stuff like this.
You are not wrong if you think of Docker. So it's a Kubernetes infrastructure, and we maintain repositories, of course, in the cloud in that case, but you cannot push from the outside anything onto the edge. The edge gets a notification that there might be an update for some of its components, and then the edge initiates the access to trusted repositories. So you can't, for example, change a repository from the outside without the approval of the edge. Does that answer your question?
Yes, partly. Maybe the maintainability, mechanical-wise, would be also interesting.
Okay, thank you very much. I think if there are any further questions, you can discuss it in the next break during lunchtime. So thank you very much again, and again, a warm applause for our speaker.